Okay, types of polarization. Let us start with that. So we will try to understand how many types are there. Types of electrical polarization, or else types of polarization. Because we are talking about dielectrics, we say it is electric polarization. In the next class, it will be magnetization or the magnetic polarization. So types of polarization or else electrical polarization. Anything is fine. Polarization. You know what is the definition of polarization already, right? The polarization is nothing but by applying the external electric field, you are producing the dipoles, or else induced charges are being produced after the application of the electric field in a dielectric material. That is the polarization. Now you are asking how many types are there? Depending on the way polarization happens, the mechanism is different. So depending on the mechanism, we have 4 types of polarizations. Okay. So what are those mechanisms we need to know? Type number 1 is electronic polarization. Let us try to understand quickly what it is. The beauty of this is the naming itself gives you what type of it is. Electronic, saying that polarization happens due to the electron movement. Very simple. Electronic polarization happens due to the displacement of electron flow. Then you can say it is electronic polarization. Let us see. So let us consider one atom. You know, atom is like this, where you have the positive nucleus and you have all negative electron cloud around it. Right? If you take the center of gravity of all the negative electron cloud, the negative charges are also at the same point. This is how an atom is. What I am saying is the center of gravity of negative and the positive charges coincides. Therefore, it is in the absence of the electric field, you see that your total charge becomes 0, or else in specific my polarization is 0 when my electric field is 0. This is the normal case while talking about the electric field. Now let us try to apply electric field. Now I apply my electric field. Then what happens? Electric field gives the direction. Therefore, this negative electron cloud, which is easy to move compared to the heavy nucleus. Right? Nucleus is heavy, so moving nucleus is tougher when you compare to the electron cloud, which is easy to move. So the electron cloud having the negative charges, they see the positive charge, they slightly come this side at the cost of the nucleus. So we say that relatively electron cloud comes towards the positive charge, whereas the positive nucleus comes towards the negative charge. This is what happens. So this picture is this complete electron cloud comes this side. So to represent that, instead of circle, I will write like this for our understanding only. Still it is circle. What happened is all negative charges came this side. Therefore, the center of gravity of your negative charge is not here. The negative charge moves slightly this side. The center of gravity, which means the net result of the electron cloud comes slightly this side. Now I represent this side instead of at the side. Relatively, the positive charge moved that side, so the positive charges I am representing here. Now you see the same charges separated with the distance. So you created a dipole when you applied the electric field. So what happened? When E is not equal to 0, you have produced a dipole. Dipole has a dipole moment. Therefore, it has a polarization as well. So your polarization is not equal. So this type of polarization we are saying it is electronic polarization. So how electronic polarization came into the picture? By the displacement of the electron cloud. So the reason or the mechanism is is displacement of. Try to focus on the test. You can zoom. Displacement of electron flow. That's why we say it is electronic polarization. Is it clear? Any doubt? Clear now? Then let us discuss about second type of polarization. Here itself, right? That is ionic polarization. Ionic polarization. This is also simple. Can you guess why does it happen? Due to the ions. So once you know the title, you can frame your own story. That is the beauty of this. You need not to by heart it. Okay. So this happened due to the displacement of or the movement of ions. Ions in a given dielectric material or in a given ionic crystal. In ionic crystal. Only prerequisite is you need to start with ionic crystal. Your system should have ions, otherwise ionic polarization will happen. Right? So best example is, let us take example NaCl. Very well known example. Na plus is there and also Cl minus. Two ions you can see. The salt that yield. So NaCl, if you consider, the structure looks like this. It has cubic structure, and if I draw cubic structure, it will be like this. This is the cube, and at the corners you have different ions. Which is bigger, Na or Cl? Inside. Cl is bigger itself. So the bigger one, which means the mass it is more. So I say it is Cl minus. Next one is Na plus. Then it is Na plus. Then it should be Cl minus. Cl minus. It should be smaller. It should be bigger. Na plus. Then it should be bigger. Cl minus. And this is how the arrangement, if we consider the unit cell, one unit cell, like this so many building blocks are there. Okay, it is like one room of a big building. So NaCl, if you consider one unit cell, it will be like this. Now let me ask, even before applying the electric field E is equal to 0, this is the case. Now do you have dipoles in this NaCl structure? Then what is the polarization? Polarization, is it 0 or non-zero?
Zero.
What?
Yesterday we told you, no current.
How they cancel each other? All the? No, I am not getting the clear-cut answer. Look at the diagram. Answer lies there. Observe the diagram. You can get it easily.
The orientation.
You are right that, yeah, orientation means how you are saying. Look, here it is there. Consider one dipole at a moment. Let us see. Let us consider this dipole. Focus this dipole. If you focus Na plus to Cl minus. So which direction is your dipole moment? Cl to Na or Na to Na? This direction. If you consider another one, this one you consider. They are opposite. Magnitude is same, the directions are different. Therefore, totally it becomes 0. So in the absence of the electric field, your polarization becomes 0 here also. Now you want to polarize such kind of crystal, ionic crystal. What you do? Same thing you apply. What happens if I apply electric field? What happens? they have already specific distance. Now they see the positive charges, see the negative charges. Now if this is my direction, plus and minus, look at each dipole at a time. These two dipoles we are focusing now, we focus on them. What happens to this dipole? This is positive, this is also positive. So it will go this side or that side?
That's right.
Yeah. So this dipole now moves from this point to this point. And CL moves from this point to this point. Okay. It comes like this. So distance is reduced. Now let us focus about this dipole. This what happened, how fluorine moved? This side. So fluorine moved from here to this side. And Ni also moves to. The direction is still different, however the magnitude changes are there. Yes sir? Are you following what is happening? Okay, one dipole stretch, other one compress. When you apply that. This happens in overall all the unit cell and also overall structure happens. So due to that, you have the dissimilar dipoles. Therefore, your polarization will not be 0 when your electric field is not. If it happens, that is called ionic polarization. So if polarization is a result of the movement of the ions, therefore the ionic polarization happens due to the displacement of the ions in a ionic crystal. Only prerequisite is you need to have ions in your system, otherwise this cannot. Right? These two are clear? If it is clear, I will move to the next one. Next one is nothing but orientational polarization. It is also pretty easy. Orientational. Name again it says. What is it? Orientational polarization. The polarization happens due to the orientation of dipoles. In what direction they should orient? Direction of the applied electricity. Right. So you are saying you have to have dipoles to start with. Okay. So if your dielectric material, if it has dipoles already, what do you call that? It has a name. Yeah, correct. Polar dielectric. So orientational polarization happens in what kind of materials then? Only the polar dielectric. So let us consider a polar dielectric like this. This is a polar dielectric material. When I say polar, I mean that it has already dipoles which are in random orientation. Any orientation. Minus plus, something. So due to the orientation, your polarization becomes 0. Yesterday we discussed about it. In the absence of the electric field, the total polarization becomes 0 because they orient in random directions. Therefore, though individually it has its own polar displacement, they cancel out each other because of the randomness. Therefore, the total polarization becomes 0. Now you are applying the electric field. When I apply the electric field, what happens? You apply the electric field. Then the dipoles, they try to orient in the direction of the electric field. Okay. Dipole is something like this. I provided a direction using the electric field, which means I am creating a force on the dipole. Yes, no? So electric force is being created. Now it is bound to rotate in this direction depending on the force, how much force I have. Okay? So it will now elect. If it is like this, it will come like this, then finally it saturates in the direction of the electric. So now they have a new arrangement like this in some sort of arrangement. they won't cancel out. So this side effectively it will have all negative charges. This side effectively it will have. So there is a net dipole moment is created. Therefore, when E is not equal to 0, your P is also not equal to 0. This polarization you produce because of the orientation of the electrical dipoles. Therefore, we say it is orientational polarization. Right? Clear? Any doubt? Clear? Then let us go back to our final type of polarization, space charge polarization. Anybody knows what is space charge polarization? You have already studied this, right? What is it? Space charge. Again, name says it. Yes. Can someone tell what it is? Can you guess?
Accumulation of charges. Accumulation of charges.
Yeah, accumulation of charges in space. Charges in space. It is called space. I'll try to give one example. You know, it may not be exact, but just for our sake of understanding. Today, your first hour you had in another building, right? I mean, second floor, another floor. So that's the new class, entirely new class. Okay, usually what happens, as soon as you come to your campus, directly you will come to your classroom without any hesitation, you sit somewhere. That's what happens. But if I suddenly ask you to go to the new class, then what happens? At the door you will spend some time, where to sit and what, you will observe. Okay, you will accumulate some time over this. So same thing happens. It is a crude way of understanding, but still it is correct. So this space charge, what is the prerequisite is, it will happen only if there is connection between two materials. We need to have material 1 and we need to have material 2. Both are connected in some way. Simple case is you are soldering your copper wire to the another microphone. Okay, wire you have taken, your sound box is there, you are now soldering there. So that is kind of junction for both of them. So material A, material B is there and you have a junction over there. This junction is called in physics interface. So what happens at the interface or the junction between the two materials that we are looking at? If you apply electric field, usually the charge tries to flow from material A to the material B, but at the junction or at the interface, they accumulate. Due to that accumulation, you will get a polarization that is called space charge polarization. Do you get what is space charge polarization? So this is there in all the materials. It is simply go and accumulate there. However, you can simply kill that if you increase the frequency. If you give more frequency, they won't have any time to accumulate there. You can kill it. So at the higher frequencies, this space charge polarization won't be there. So let us look at the dependence of frequency also now itself. Then we can finish. Okay. The dependence of frequency. So which is having greater frequency dependence. So the net polarization that we will be studying having the dependence of frequency, dependence of frequency. Polarization, how does it depend on the frequency? Let us look at it. Why frequency matters? First let us understand. Why are we talking about the frequency? Effectively you produce some polarization by applying the electric field, but now you are looking at what frequency. You imposed a condition. Why is it important? Why frequency important? No idea. Do you know what is frequency? No idea. Why frequency is important? How do you communicate through the mobile? How do you communicate?
By varying frequencies.
How do people communicate when they travel over, aeroplanes? How do they communicate? Frequency does matter. The radio that you are using and the mobile phones that we are using, everything is set up for certain frequency range. The internet that you want to have, high fast internet, you are going to the optical fiber, which means the frequency. OnePlus mobile recently came with, you touch it, instantly it opens. What is it happening actually? The frequency, response frequency, everywhere, depending on the applications, you need to look about the frequency. Satellite applications, you need high frequency applications, high frequency. So somebody they are sending satellite there. What next? It's not sending. You need to get the data from there. That is more important than sending. Rockets will go and sit somewhere. But what is important? How much data you got from there? You need to get the communication. So the communication demands a specific bandwidth of frequency. That's what in your experiment you try to do in one of the experiments. What is the band, frequency band? Where does the resonance happen? Why do you discuss about the resonance? At that frequency range, your current is maximum when you apply the electricity. That's how now you got it. So in that frequency range, you will get a better audio or the better signal. So if you want to use for the applications, you don't need any rest of the frequencies. You focus on that frequency. So that's the beauty of doing experiment, and if you can understand. Now let us quickly look into the frequency dependence of the polarization. So how does it depend? Let me do it quickly. Frequency in the hedges I am plotting on the x-axis, while the polarization total on the y-axis. When I say polarization total has how many components? It has PE due to the electronic, polarization due to the ionic, polarization due to orientation, polarization due to space charge. Yes. Okay. So I wrote it as PT. This is the total polarization. Now at the low frequency, from 0 I started. At the low frequency, till certain 10 to the power 3, which means kilohertz. Till the kilohertz, you have all the components. Then, once you cross the kilohertz, one component will drop off. What will be dropped off? First one to drop is space charge. You will not have the contribution from the space charge. So, PS will not be there. Above 10 power 3 hertz, space charge polarization will not be there. Then, which one will get dropped off? Orientation. PO will get dropped. So here we have all PS plus, PO plus, PA plus, PE. But here you have only PO plus, PA plus, PE. So in between you lost PS component. Only these three. That will be there till 10 power infrared range, or 10 power or micro. I need to look at the notebook, but let's say till 10 power 6. Then orientation is nothing but this orientation of the dipoles in the direction of the electric field takes huge amount of time, because you are applying the frequency is nothing but you are giving the motion. Positive side, negative side, positive side, negative side. So the dipole, it has to orient in the positive side, then it has to go back to the negative. It is difficult for the dipole to do that. If you give enough time or else lower frequency it can do. If you ask the dipole to quickly switch your directions, it is tough. It cannot do it. So above certain range 10/6, you will not have PO. PO will be dropped. So you will have PA plus PE only. Then at the range of 10/12, your PA will be dropped. Which means ionic polarization will not also be responsible. Above 10/12, you will have only voltage. So there is a drop in the polarization with the frequency.
The PE electron.
PE electron. So in the optical range, which means if you go back to 10/15 or some frequency about 10/15 hertz, that is you will call optical range, you will have mostly the electronic polarization only. Now you need to look for the materials with certain polarization depending on where you want to use that material, at what frequency range you want to use. You need to look for the materials. Okay, what different contributions of frequencies are. Right? Is it clear?